Hi guys, my name is Raj. I was here last week doing an online tutorial. Today we also have...
I'm Colin. I have not been here before, but you guys have probably seen me on Piazza.
So the aim of today is to go through associative property. I know a lot of you guys struggled with it, especially since not many of you did the extra credit part. So today we want to go through the whole thing.
Mm-hmm. Yeah. Including the extra credit.
Yes. So we are now going to go on to Dr. Java, and the rest of this tutorial will be on Java. Okay. Okay, so I hope you guys can all see my Dr. Java screen. So we will start by going through every step in the instructions. So the first step tells us to design a class called Associative. So let's start with that. There's our class. We completed step 1. That's 2 points, people.
So coming up next, then we will write a main method. So you should know this by now. Public static void main string args, and then what are we putting inside of it? Well,
now we need to remember that we need to create an object of the class. So we can access methods within the class. At the moment, we don't have a constructor, so we can leave the parentheses empty. Okay, next step.
Then we need to create 3 class variables, all integers. So these will be the values that are passed to everything, and that will be input by the user.
Remember, these are global variables. So because they're global, you can access them from any method without having to initialize them within the individual method.
And you can access them by using the class name A, which we've created here, A.x or A.y to access each one of those variables.
Okay, so now we have step 3. We need a constructor. Remember, the constructor has the same name as the class. So currently we have an empty constructor.
And but step 4 tells us that we need to assign values from 3 parameters that are passed to the constructor and assign those variables to the class variables that we made, the x, y, and z. So we can take in variables, that's int x, int y, and int z. Now what this is doing is it's taking in new variables. When we declare int x right there, then that creates a new variable that didn't exist before. So that is different from the int x that we made at the very beginning.
A good way to show this would be we can create new variables by changing their name. I'll leave z as it is because we would like to show you the difference between having a variable with a different name to having a variable with the same name. So when initializing x1, we can just say that x is equal to x1. However, when we are initializing z, we'll have to do this dot z is equal to z because we need to...
When the class variable is referenced by this. So whenever we say this dot something equals that same something, that's because this variable has the same name as this variable. That's this one versus this one. But when we say this dot something, that will always mean the class variable. So as opposed to the method variable.
So we'll go back to taking in the class variables because that's what is told to us in the instructions. Okay, so now we have initialized our variables.
So next we need to, for step 5, we need to write two class methods, first two and last two. So, they will return ints. So it's going to be int first two and int last two. So inside of them, the method first two should combine the 3 class variables by grouping the sum of the first 2 class variables, then multiplying the result by the 3rd class variable and returning the result. And you guys can see.
So here we have grouped the first two variables, and now we need to multiply it with this 3rd variable.
And so then we are just returning that value because
we've been told.
Yeah. Yes.
Also, keep in mind that our parentheses here are empty. If we hadn't made variables x, y, and z global and we made them local inside main, we would have to take them in as parameters. But since that's not asked of us, we'll leave it as it is. So last two does the opposite. It will return the first variable plus the grouping of the second multiplied by 3rd variable. Okay, so now we've finished the majority of the code, and the rest is just in main.
Just the rest of the main method. So the definition for main, your program should create a new scanner object. Now, when we look at this, first, we don't have scanner right now, so we need
to import.
So that's just as soon as we see scanner, we're doing that.
Then we have to create an object.
And we're creating that on system.in.
Okay.
Then the main method should then create a new associative object, which we already did. We were a little bit ahead. We can,
we can,
yes, yeah. We'll skip that part. And then the main method, and print out 2 lines like that to display the result of calling your first 2 and last 2 methods.
I'd like to remind you guys, if the instructions tell you to print something, please print them exactly as the instructions tell you, because a lot of times you find that the output doesn't necessarily match character to character the output which we're expecting. And I mean, these are easy points. Please don't lose out. And also, when you're coding, generally, it's important to keep in mind that the output should be exactly as outlined by whoever you're coding for. It's really important, because then your code might throw errors later on, depending on how complicated your program is.
And right here, we are reading all of you guys' code, so we know what you're doing. If you say, like, if you display just the answer instead of saying grouping the last 2 terms and grouping the first 2 terms, and instead of putting it out exactly, we know what you're saying. But if any other program is grading your stuff, not a person, which is what will happen most of the time, because most people aren't reading code, code is just executed. So if it doesn't match exactly, then there can be problems. So we are said that we are told to input the integers in the first place from scanner. And then we are that's just the prompt, and then now we need to actually take those in from the scanner.
Okay, here we're using next int because we're only reading integers. Now that we've read our three integers, we need to pass these integers into the parentheses of our object. Remember how we created an object of the class? Our constructor requires three integers, right? So we need to put them in. So if we put them in here, this will give us an error because we're creating the object before we create variables A, B, and C, right? So it's important to put this in afterwards.
And then we see another common error here, and that is that at the moment we have an A and another A, two different objects with the same name, which is going to have a problem. So we're just going to rename it. Then we need to, now that we've taken the things in and set them as the global variables, then we need to just print it out.
Print out the outputs. Okay, so again, print out the outputs exactly as you've been told to. It's really important. Okay, so it's important, so you need to make sure you have all your parentheses and spaces correct. This might be a bit tedious, but keep in mind that it's important.
So the way that we're doing it right now is we are just using print line, which is, it's a good way to just print a bunch of stuff in individual snippets. But an easier way that you will see everywhere throughout coding, and if you continue on programming later on, especially in C and C++, is something called printf. So instead of using the print line method, system.out.println, you can use system.out.printf, which is called print formatting. So then if we want to do that with the last two terms, we can do system.out.printf, and starting off the same exact way, grouping the last two terms, but then what we can do is we can use these little variables that will be replaced.
So in this case, we would usually have A here, right? Instead of this, what we're going to do is substitute this with the following. This is basically something that allows us to substitute this allows us to substitute the %d with a %d stands for an integer.
Yeah, okay? Decimal, any kind of decimal number.
Any kind of decimal number, right? So here, what we would have this way, it allows us to, it saves us from having randomly concatenating variables, and really saves a lot of thought process, because this way not only takes time, but it's also annoying. So here we have %d plus %d again. This %d is a substitute for b.
So each time we say %d, it'll be replacing a variable. But then at the end, somehow the program needs to know what these variables are what the %b is representing. So we need to pass them at the end, like we are doing right now.
Also, we found that a lot of you guys are having trouble calling methods. So remember, the way to call methods is you have the name, the object of the class first, dot. You need to use a dot operator, and then the method which you want to access. And then you need to have the parentheses. Remember, methods always have parentheses. And also, since in this case our methods don't take any parameters, we can leave our parentheses empty. However, if they were taking parameters, for example, int a, then we would have to specify when we call the method that we want to pass an integer in here. So we could have 1 in there, or we could have a variable that stores an integer. In this case, it would have been 8. But we're not doing that right now. Okay, so let's try compiling and running this. I don't see any errors, but oftentimes it's possible. Yes. Okay, so there is an error because I can't type next. And there's no such thing as next. Okay, good. No compile time errors. That does not mean there are no runtime errors. Okay, so we'll enter in our 3 numbers, 1, 2, and 3. And we have our answer. Is it correct?
2 times 3 equals 9. 1 plus, yeah. It looks like it. It looks like there might be some extra spaces here, I think.
Yep.
But
so please keep in mind that spaces, I mean, if a human is reading them, we know they're spaces and they're not actually errors. But if another program is checking your output, which would be the case if you have a lot of students submitting programs, then we won't be checking them manually, and we'll have a program do it.
now, a note on printf. Right here, print line automatically, since it's printing a line, it automatically returns to a new line. So if we
run this code, you can see that when the first time when we use print line, after typing after typing out the output, it automatically goes on to the next line. Whereas when the second time, the end of output symbol, this greater than sign, is it greater than? Yeah. Greater than symbol comes right after the 7. This is because there hasn't been a next line added to the end of this output. So if I were to to print out the last 2 terms output first, I would have the output would be 1 single line. So I'm going to compile and run it just to show you. So yeah, as you can see, the output is 1 single line. This is because printf does not, at the end of the output, it does not move on. It doesn't tell the program to move on to the next line. So what we have to do is have a \n.
That's just a character that represents a new line.
So if we run this now, it should print it out on 2 lines. And remember, change this back to where it should be, because otherwise the output would not match the required output. Okay, so yeah. Okay, so now that we're done with the first part, or the main part of the project, we would like to move on to the extra credit part. We noticed only 1 person submitted the extra credit part, and I think that it would be quite useful if you guys tried or attempted in your own free time to do the extra credit part.
Of course, we're going to tell you how to do it now.
Yeah.
So,
I mean, if you don't get it,
right,
you can always look into this video, but please try attempting it yourself first.
So if you would like, pause the video right now and then try it on your own, and then come back and watch the rest. Check your answer, see what happens.
Okay, so Now let's go on to the extra credit part. Do you want to read out what we have to do?
So the extra credit says, create one function for each of the 5 arithmetic operations: addition, subtraction, multiplication, division, and modulus. So each one of the, and each function is going to be a method. So one for addition, subtraction, multiplication, division, mod. Each function should take 3 parameters and return a Boolean value specifying whether or not the operation is associative or not, given the inputs. You can achieve a Boolean result by utilizing the equality operator, double equals. Modify your main function to report on which operations are associative in a user-friendly way. So in this one, there is no output to check against, because it's just saying do it in a user-friendly way.
Okay, so let's start with addition. So we need to have a method that returns a Boolean, right? So here we go. Method will return a Boolean, and it is called addition. It'll take in 3 parameters. Okay, it'll take in 3 parameters, but since our parameters are already global, we don't need to specify them within the parentheses.
But we can anyway, so. And again, these int x, y, and z, those are different from these globals that are at the top. So the ones inside the method, it would be the same as if we titled them different things. But we could title them as x, y, z if we wanted. But just note that they mean different things. So this dot x refers to the one in the class at the top, but then the one here refers to the one in the method. And by default, if you just type x in this method, it'll just do the one that's in the method right there.
If you want to access the class ones, you can always do or rather associative. Or actually, no, we can't do that. Never mind. It's this dot.
This dot.
If you want to access the global methods, you can do this dot. Okay. So for now, we're going to change the variable names because typing in this dot requires more work than typing in A, B, or C. Okay.
So then we need to have it do something. We need it to evaluate whether or not a certain condition is associative. So we are seeing whether the grouping the first terms, the first 2, is equal to grouping the last 2.
Okay. So in this case, we could just do x plus, or rather, a plus b plus c is equal to, remember when we're checking for conditions, we need 2 equal to's, and we're checking a condition. That's why we need to have an if statement, because if statements are used to check a condition. However, since you're only checking one condition, it's not required that we have an if statement, and we can just return true or false. So this, so the associative law is A plus B grouped, the grouping of A plus B plus C, or A plus the grouping of B and C.
And another way that we could do this, if we wanted, is we're using the variables up here, but we could just run the methods that we've already written. So we could just, no, we couldn't, because that uses multiplication. Never mind. Forget I said that. I apologize.
Okay, this is all we need to do. So this method will return a true if A plus B, the grouping of A plus B plus C is the same as A plus the grouping of B and C. Now let's do subtraction. So again, we're returning a true, or we're returning either true or false. So the return type has to be Boolean, and we can call this subtract. Have I spelled that right? Okay, so this time I won't include any parameters because we already globalized the parameters, so it's not required.
Although technically the definition says we're supposed to take 3 parameters.
Yes,
but
because the instructions do tell us to take in 3 parameters, I will create 3 parameters. The instructions are very important. And oftentimes, even though your code is completely right, and I mean, it does everything it's supposed to, and it's probably more efficient than ask, it's important to follow the instructions because you will find that more times than not, even though your code may be more efficient, better than what they ask for, you will be marked down. So always follow instructions. So with subtraction, again, let's do the same thing we did before. So here are parentheses. So if the grouping of A minus B minus C is the same as the grouping of A minus the grouping of B minus C. I'm pretty sure you'll find what I'm saying pretty confusing because I'm using the word grouping a lot, but hopefully you get what I'm trying to say. Okay, so this is it.
And as we know, subtraction is not associative, so this should not be. I mean, at this point, it's just testing on a case-by-case basis. So it won't always say.
If you have a positive number, so if you have 1 minus 2 minus 3, this should give you minus 1 minus 4, right? Yeah. Okay. And then if we do it the other way, if we do 1 minus 2 minus 3, this should give you 0. Right? So, oh yeah, it should give you 2. So minus 4 is not the same as 2. So it's not associative.
So this condition, or this double equals, would return false, because that is asking, is this equal to this? And the answer is no. So it'll return false.
However, if you had a case well, no, not this case specifically, because this will give you minus 1 and this will give you 1. But there are certain cases where this would return true because there are certain numbers. I mean, I can't think of an example at the top of my head, but there are certain cases where it may return true.
Well, for one instance, if they were all 0.
Yeah,
So
that's right. There we go. This will give you a 0, and 0 minus 0 minus 0 will also give you a 0. So in this case, 0 is in fact equal to 0, so it will return true. But that's just, like we said, it's a case-by-case basis and doesn't give true for it doesn't evaluate all possible, like, it's not a generic case, it's a case-by-case. Okay, let's move on to multiplication before I talk myself. Anyway.
So this one, we're doing the exact same thing, except replacing it with the multiplication symbol instead of subtraction.
MUL. Okay, so as instructions direct, A, B, and C. Okay, same thing again. I'm just going to go ahead and copy paste what we have here and change the symbols. So multiplication, as you guys all know, is associative. So this should return true. So it's good to have comments in the side, because this allows us to know that you guys know what you're typing, and at the same time, we get a good idea of how your thought process works. Okay, now we're gonna, yeah, please don't mind my spelling. Anyway, now we're gonna do division. Division is a special case because there are certain things you can't divide by, or if you do divide by it, it will give you a different answer. For example, dividing by 0.
So we can try it with just the normal thing that we had done before, like just copying and pasting the same thing. If A divided B divided by C equals A divided, then the grouping of the second two.
But what we're going to do is we're going to run this and try and show you why this would give you why this would give you an error. So we're going to do this. Okay, so.
Oh, well, we haven't written that main method.
Yeah, so in the main method, we shall comment out these two.
I'm missing an I.
Right, yeah. Okay, so we're going to comment out these two. Oops, I haven't commented out the right thing. Okay, so we're going to print is percent P, and then over here I'm just going to call the division method.
Percent B. B.
Yeah.
And for a Boolean?
Oh yeah, it's.
Is it a B? And C, this is a.
Okay, so there we go. Oh, variable.
And we made one of the classic mistakes, and that is we did not put parentheses afterwards.
And also note that our parentheses are taking in parameters, so we need to put in those parameters. As we have A, B, and C already declared here, we can just use the, oops, what did I do? Oh, yeah. Okay. See, that's why it's important to always compile your code before you submit it, because oftentimes we don't notice these small typos, or not typos, just errors, because we just didn't think of it at that point in time. So I'm going to have my 3 integers, and oh, we have an error, but this time it's a runtime error. The arithmetic exception divide by 0.
That's not a...
And okay, so how would you read this error? So the line right below the error, it tells me that there's an error at line 37. So if I go to line 37, and it's also in the method, it's in the division method. So if I go to line 37, ta-da, this is where my error is happening. This is because I am dividing by an integer.
So right now it's taking 1 divided by 2. If it's A divided by B.
1 divided by 2.
And this is integer division. Remember that whole thing? So 1 divided by 2 does not equal 0.5. It equals 0 because
it's an integer.
It's just an integer.
Exactly. Integer always takes the lower bound. Okay, so then when we try dividing by C, what we're doing is really 0 divided by C, which in this case is 3. So here you're...
And the answer is appropriately 0.
Yes. Now if we do the other side, we have 1 divided by, we have 1 divided by 2 by 3, which in this case, 2 by 3 is, again, 0. And when you try dividing anything by 0, it gives you an error, the divide by 0 error.
This arithmetic exception.
Right? So we don't want this. How do we change that?
Well, it just so happens that the double type instead of the int type actually does not have this divide by 0 error.
Why? Because the double, instead of storing, so you know how we did, I want it, let me type. Instead of doing how we had 1 by 2 was equal to 0, instead of this, the double will store this as 0.5. So you're no longer dividing by 0. So for the second case especially, you know how it was 1 divided by 2 by 3? This will now become 1 divided by 0.666 rather than just 0.
So we can check this using the interactions pane. So if we say 1 divided by 2, these are just integers, so it's 1 integer, 2 integer, so the answer is 0, as we had expected up here. But if we cast them as doubles, so double 1 divided by double 2, then the answer is 0.5. And interestingly enough, if we cast, another problem is if we do 1 divided by 0 or just anything divided by 0, then we get that arithmetic exception. But if we cast it as doubles, then double 1 divided by double 0, it prints out this nice little thing here.
Instead of giving us an annoying divide by 0 error, it'll print out the word infinity for you. Also, another thing you can try is doing this. So instead of having integers entering in double values or floating point values, that will also not give you an exception. So I'm gonna go ahead and finish this. Remember, every single variable needs to be typecasted.
So this is just making the compiler think that it's a double. It would originally be, A would just be an int because we declared that up there, but then in this case we're saying we know what we're doing, we are calling it a double.
Yep. Okay, so now that it compiles nicely, we are going to run it. And shouldn't give us an error. Yes. And it also gives us the right response because division is not associative.
But now what the interesting thing is, if we run it again, if we put in 0, 0, 0.
Oh, I need to
compile. Then what happens?
Still not associative. Why?
I wonder is, I don't know how that infinity thing works actually.
Oh, oops, I forgot.
Right. But when it compares.
Okay. Funny.
So I'm just thinking how it works between the when double prints out infinity.
So this is the other one.
And then if you were to compare these two, they're technically not equal.
Yes.
They're not the same reference. But
anyway, let's move on to
quirk.
Yeah, that's just a little quirk.
It just works.
Okay, so now let's move on to modulus. I wonder if you guys all know what modulus does. Modulus is division, but it returns the remainder. So if you have 2 divided by 3, technically this is 0.66666666, right? But if you want the modulus, it'll do 2 divided by 3 is equal to 0 remainder 2. And what it returns is the remainder. Okay, so again, because modulus involves dividing by, it is important that we again typecast our variables as double, otherwise it'll again throw errors. So let's do this.
And the modulus operator is, in fact, the percent instead of the divide, the normal slash for integers, or for division, it's a percent.
Okay, so I'm going to go ahead and copy.
Oh.
Never mind.
Sorry.
That didn't work. Sometimes I wish my hands worked as fast as my brain. Okay, so now we have to switch the divide by modulus. So another thing to remember is because division is also not associative, modulus is also. Just like how division is not associative, modulus is also not associative. We can show you an example. So let's run this with 1, 2, and 3. So it tells you that. Oops, sorry, I forgot to change this. Modulus. And let's run this. Okay, so apparently it works.
It says true for this one.
For this case.
Yes.
Why does it say true for this case? So we have 1 mod 2. 1 mod 2 is equal to 1. Okay, so then it takes this answer and does 1 mod 3, which is also 1, because when you divide 1 by 3, you get 0, remainder 1. So in this case, the answer is 1. And then if we try the other one, the other grouping system, so we have 1 mod 2 mod 3. In this case, remember how we always do whatever's in the bracket first? So in this case, it'll be 2 mod 3 will give you an answer of 2. So we have 1 mod 2, which is equal to 1. If we take another, maybe mod is, okay, if we take different values, let's try taking 2 and maybe 4. So values we've taken are 2. What have I done? Okay, so wait. Let's not do that. Let's compile this and run it here. We take 2, 2, and 4. Well, I guess you can keep running it until you find a case that it's not true. Looks like it is true. It makes sense because it's always, the remainder will always be the same.
It is also not associative.
Yep. Okay, so here we've got a case where modulus is not associative. So let's talk you through this. So we have the first case which we'll try is 1 mod 7. I'm going to put this in comments because I don't want to make an error later. Anyway, okay, so 1 mod 7 mod 3. So how would you go about doing this? So first we have to do what's in the bracket. So we have 1 mod 7, which is equal to 1 because 1 by 7 is equal to 0, remainder 1. So that's 1. And then the second part would be, then we'll substitute this value here with 1. And we get 1 mod 3, which, again, any number, 1 mod any number will always give you 1.
Yes.
Okay, that's the first. that's the first part. Now let's try the second one. The second one would be 1 mod 7 mod 3. So in this case, we have to do what's in the brackets first. So we will do 7 mod 3 first, which is actually also equal to 1. Why? Because 7 divided by 3 is really 2.333 over 3, which is, wait, no, it's actually 2.33333. So what another way of saying that is 7 over 3 is 2 remainder 1. So the modulus is 1 because the remainder is 1. And then when we do, so we can substitute 1 over here, and what we'll get is 1 mod 1. So 1 mod 1 is the same as saying 1 divided by 1, which is 1, but there's no remainder, right? So the remainder is 0. So this obviously is not the same as this because 0 is not the same as 1. That's why modulus is not associative.
So you guys don't really have to look at how modulus works and everything, but it's a very useful thing to know, and you can use it a lot in programming. Another way of looking at modulus is that it is basically like a clock that just keeps going around in a circle. So as we said, 1 mod 3 is equal to 1. Then 2 mod 3 is equal to 2. 3 mod 3 is equal to 0. And then 4 mod 3 is equal to 1. 5 mod 3 is equal to 2. So it just keeps going around in this.
6 mod 3 would again be equal to 0.
Exactly. 6 mod 3 equals 0. So it just keeps going around in this loop there. So that it's just a useful way to, if you need to get some answers that are looping over and over again in a lower fashion, that
you don't really need to know this yet, but we once you start getting better and better at coding, you'll learn more about algorithms, and when you start looking at data structures, this will be very helpful, especially when you start looking at data structures. That's a lot in the future, yes. So it's just a little need to know.
Yeah, just a way to know how this works.
And also, it's kind of important to know why we're using modulus because it's important. So yeah. So here we've basically got our extra credit part done. So what I'm going to do is now write out the in main we're going to have to call all of these methods. So I am going to go ahead and just copy and paste a bunch of times and just change what we're doing. So first we're doing addition. Oh, nope, that's wrong. Okay, so addition, and then we have to change this to addition, and then we have subtraction. And then we had multiplication. And then we had so this one was I hope I've spelled everything right. Yeah, it seems, yeah, no compilation errors. So we're going to enter our 3 standard numbers, 1, 2, 3. Oh, there we go. Remember how we talked about printf not going on to the, not having a next line element to it? So we need to have that here. So let's compile and run it. 1, 2, 3. Okay, so for the case of 1, 2, and 3, addition is associative, subtraction is not associative, multiplication is associative, division is not associative, and modulus is associative. So in general, though, when you do addition, you'll always get associative. When you do multiplication, you'll always get associative. With subtraction, division, and modulus, it's a case-by-case basis.
Now, one other thing that I just wanted to hit, we've finished it. I just wanted to talk for a minute about scanner and just how it works. So right now, it is scanning the system.in, so just whatever you're putting into the input. So right now, if I were to put in 1, it accepted it. I hit enter. So I hit 1, enter. So what we're doing right here is in main, in.nextInt. So it got an int. It's just constantly scanning until it gets an int. So it got an int. So it returned A.
So yeah, it stored this int 1 in A. But now it needs another int. And I haven't given it another int. Instead, I press enter. So it'll ask until you give it what it wants.
Right. So I just wanted to explain, we've always been doing it as 1, 2, 3 with just spaces in between, but you can do it any way you want. You can put in a bunch of spaces or however, or you could hit enter after each one and then it would.
Another thing to keep in mind is, what if you enter more numbers than it asks? It'll only take in the first 3 numbers and it'll ignore the rest. So yeah, and oh, another thing, what if instead of giving it numbers, you give it a letter? It'll give you an error. So one thing you'll learn in the future is how to prevent such an error. Okay, so now now that we finished our code, we'd just like to talk about submission. We love to correct your work. We like seeing you guys improve, but sometimes you guys don't always give us the right file. So a couple of you guys copy and paste this into the comment section. Don't do that, please, because if your code is long, you have a lot of comments, we have to literally unwrap your code. So please upload a file. And the file that we want you to upload is a .java file, not .class, okay, not a .class file. Also, do not upload a .java with a squiggly line, because I mean, we can't do anything with this file unless we actually decode your file.
It's just a temporary file used by Dr. Java. So the one we care about is the one just .java. That is the actual source code that you wrote.
Yep. So in this file will be called this code which you've written will be saved in a file called associative.java. You'll also have a file called associative.class, as well as a file called associative.java squiggle. Don't submit these, because then we can't check your work. Okay, don't submit these. It's important. Please don't submit these.
And then
and don't write yours in a comment. Just upload a file. It just makes our lives a lot easier, especially since we have to go through all of your submissions. Okay. So yeah, that's it for today. Thank you.
Hopefully you feel better about how, especially like how to do the associative project.
Yes, and please give it a try once more if you feel you didn't do as well the first time. And hopefully this video was a lot better than last week's. So we'd love for feedback. Thank you, and we're done for today.